Hi, thanks for watching. This is one of the lecture halls in Strathclyde University in Glasgow, and this is November 2019, and this dude here is a NASA scientist. He's Australian and he's a Mars expert, so I went to the lecture. I was hoping we could get him to share the truth. No luck there then.
And that'll be your master of ceremonies for tonight, while Paul's away. Firstly, I'll make some of the session before, as usual. David Deacon, coming into the back.
Quite good tonight. The first one is the usual acre movements, observing at the observatory on acre Strathclyde Uni. The first one is on the Thursday, the 5th of December. That also includes Colin's imaging group. So that's we usually gather between 7 and 7:30. So that's Thursday the 5th of December. The next observing night is the week after, Thursday the 12th of December. That includes the beginners group, which is run by Warren. I don't think you see it tonight, that's the 12th of December. The next notice is one that's taking place, an event that's taking place in Edinburgh on Wednesday the 4th of December. At 2 p.m. It's an afternoon lecture. It's being presented by the Institution of Engineering and Technology. It's titled Large Telescope Engineering Challenges. It's basically a talk about the engineering challenges faced during the building of the European Space Observatory's 39-metre telescope in Chilean desert. It's a free event. It's been held in Napier University. If anyone's interested in that, I've got the details. Next up, just a reminder about the Dark Skies Weekend, which is taking place in Lancaster Food Studies Centre in February. That's on Friday, the 21st of February to Sunday the 12th. There's still places available. It's £140 full board. That includes packed lunches on Saturday and Sunday. You do have to pay a £70 deposit first of all. You should send your cheques to our treasurer Alex. Alex is actually here tonight, so if you want to hand in a cheque tonight, you can do that as well. If we're not observing at night, there's also plenty to do during the day as well. There's hill walking, there's Keswick's just a few miles away. You can also go for an afternoon walk in Harvard Lodge. So it's a good weekend socially as well. And just a final couple of notices. Our membership secretary, Julian, unfortunately can't be here tonight, but he's asked me to pass on a couple of messages. If you actually have sent away your subscription renewal to Julian and we haven't received any word or confirmation from him, it's possibly because he wasn't able to read your email address.
Okay, thanks. Thanks, Julia. To continue, tonight, I'm going to look for the search for life on Mars with Dr. Alistair Tate. Alistair is Canadian. He's an Australian. From all the way around the world, especially for you tonight. Try James. He's not from Stirling. And I'll just. It's the Commonwealth Relatives Fellow. That's a clue as to his intimidating origins. If you do what Mr. Ernest Rutherford and he's at the University of Stirling. Alistair's published astrobiologist, and I don't know where to say this from. Meteorists. Taken from him. Okay, this could be a fun lecture. And Alistair's come to research is investigating meteorite weather on Mars. He's conducted several meteorite recovery expeditions in remote regions of Australia, which I have learned over dinner tonight. I now know the Nullarbor very intimately. And he has gone to expedition in Australia and is a former NASA Lunar Planetary Institute Intelligence Science Team collaborator with the Athena Instrument Team for the NASA Mars Exploration Program. Alistair's research and expeditions have been featured on Radio National Australia, as well as on the Australian Broadcasting Corporation Science Education Program. Without further ado, I'm going to hand over to Dr. Alistair.
Thank you very much for that introduction there. So tonight, ladies and gentlemen, we're going to go on a little bit of a journey. And this journey is going to cover a historical aspect of our science. And that really is the still yet to be answered question, the search for life on Mars. This is, despite its extraterrestrial subject matter, it really is a human story full of optimism and unfortunately in some cases a little bit of a downer in some cases. But it really just shows the fact that it is cathedral thinking in its grand outset, trying to find one of the oldest questions that we can possibly answer. So I will be going over these sort of stories and histories today. I will also talk a little bit about my research, because I have a captive audience and you have no choice. And I will also just talk about where we're going, what is the state of the science, and what is the upcoming missions, and are we any closer to answering this question. But before we do anything, we should really come close and face to face with the subject of our fascinations throughout the generations, and that is, of course, the fourth planet from the Sun, which is the planet Mars. Now, Mars itself is about half the size of Earth. It has a day roughly about the same length of day that we have. It even has the same axial tilt, which means that it has seasons very similar to Earth. Unfortunately, that's where the similarities end. When it comes to things for life, we need things such as water. Today, Mars is very, very dry. But in the past, Mars had a lot more water. And the reason why we think it doesn't have water on the surface today is essentially because it was smaller, it cooled off quicker. And that means that it lost its magnetic field in the center of the planet, which allowed its atmosphere to be stripped, and that led to a lack of atmospheric pressure to keep water in a liquid state. And of course the moon's over there, and nothing really lives there at all. It's not very good for life. Mars itself, geologically speaking, if you want to be very, very quick, can be divided into two halves. You have the bottom half down here, which is full of craters. So this is the Martian highlands and the southern highlands, and it is cratered, so therefore it is older. Now, if you have a look at the top part of Mars, that is actually quite shallow, and it doesn't have as many craters on it, which means that it's a younger surface. And we think that's where the Martian ocean once was. But Mars itself is a very pretty planet, and inside that you can see that there's lots of things that are very Earth-like. We've got the poles, the icy poles. We've got different types of terrain on there. You can see some wispy terrain. But what's really cool is, I don't know if you can see on this image, but you can actually even see the moon Phobos. There it is. It's very, very tiny. It has two moons. We have one big one, but it has two tiny little ones. And this is also a fantastic photo where we can see Phobos, but we can also see the shadow on the surface. And there's Gale Crater, where one of NASA's rovers is currently trundling on, doing science. And because of these lovely orbiters in space, we see some absolutely fantastic photos like this one here. This is also Phobos, and in the background, yes, that is Mars. So we can see how close these things actually orbit to the planet. It would be quite spectacular to see these things moving across. So Mars itself is a very dynamic planet. Our image and our understanding of Mars has changed, and that's what I really want to talk about with you today because it has really shaped our society, everything from the way we view ourselves, view the planet, science fiction, and right through to current science itself. So without further ado, let's start in 1877 in Italy. Milan to be exact. There was a gentleman, scientist called Giovanni Schiaparelli, and he made some observations of the red planet in an observatory near Milan. And he discovered these, what he called canali. And he also thought that this was an ocean at the time. This is sort of upside down from what we see it on most models. There is Hellas, which is still a very much geological feature on Mars today, but we now know it's a large, giant impact crater. But here he is, he even named some of these things, and we thought that this was very, very interesting, very, very important observation of Mars at the time. And the Italian word for canali translates to canals, or gully, or channel. This guy was only talking of a pure geological phenomenon. He didn't think that there was, civilizations on the planet channeling out gullies. But however, this word here can really captivate the imagination of certain people, because in English, canals is a very much a human-constructed feature. And it captured the imagination of Percival Lowell, who is an American astronomer, and he really, really loved Mars. He wrote several books on the subject, and he took this word canals and really, really went to town. You can see that he's got a lot of naming conventions up here. We have the Arabia and Eden, Neath Regia, Elysium. Some of these things still remain today in our naming conventions of Mars, and then other ones are not quite there. So his imagination ran completely wild. He was like, this is proof positive of civilization on Mars. They're building canals, they're industrious, hell, they can even do it in like a couple of years. Very, very, very fast apparently. And I wonder where he got that idea from. Keep in mind, he was making these observations right at the time when humanity was conquering nature, just, bulldozing entire rainforests, going through the desert, and making canals. So it also influenced science fiction, right? War of the Worlds, probably one of the greatest science fiction novels ever written, because it really just kick-started the whole field. We even had Edgar Rice Burroughs with Princess on Mars, and it really, really shaped the way society around the world viewed the red planet. However, despite all this public attention and outreach, really wasn't the scientific consensus at the time as that's what it made out to do. Who here is an astronomer? I think a few of you are, right? Cool, right? In the astronomical society, you're probably familiar with this thing here. He wasn't seeing gullies. He was looking at an optical illusion where it is, in fact, the retina being projected, the veins in your eye being projected onto your retina. So he wasn't actually looking at canali, he was looking at the veins in his eyes. And you can tell this because this is Venus. Not only did he start seeing them on Mars, he started seeing them on Venus. He started seeing them everywhere. Yeah. Something was up, most people knew about, in the scientific literature, knew about this at the time. And also at the same time, we're starting to see some really interesting new technologies coming along, such as spectroscopy. And the first measurements of Mars were not exactly optimistic. It's got no water in the atmosphere, it's mainly carbon dioxide, and based on some other it's pretty cold. So it's cold, dry, dead planet. So at the moment, optimism for life on the planet was, in the scientific community, not very high, but in the public's eye, it was quite large. And here is a very famous artist called Chelsea Lonsdale. He made a lot of beautiful drawings, I think in the 40s and 50s, about these signs, and he tried to make really, really scientifically accurate paintings at the time. And you can see he was looking at canals, maybe some algae, not very much, but certainly no civilizations. And that was pretty much the way we viewed Mars for the best part of half a century. Canals on Mars, despite them being disproved almost immediately, and it's very cold and dry. So enter the space age. This is another one of this guy's lovely drawings. You can see that almost looks like Elon Musk's rocket. It's really great. But at the time, there was a German rocket scientist who had defected to the Allies at the end of the war, called Werner von Braun. And he was part of, I believe it was Operation Paperclip, and he was essentially there to develop the Nazi rocket program and turn it into something that the Americans could use. Now, at the same time, he was also a German and also, just recently an enemy, so a lot of the technology was offset to the US Navy at the time to develop the rockets, and he and his people were not really involved with that for the longest time period. So when NASA was essentially almost started, he decided to go to the people, go to the American people, and try and convince them of this grand future of America and space. It's something that we can do now, it's just not science fiction. So he teamed up with Walt Disney, and they changed the way society views Mars again. They made this beautiful animation. It's about a 45-minute documentary showing about how we can go to space, how a rocket works, and even going into these cucumbers on Mars. So really, and which they called a low-level amount of vegetable life on Mars. And like, if we found that today, that'd be awesome. But unfortunately, we have yet to find any space cucumbers. So at the end of the 50s, things were looking pretty good. We just started going into a space race with the Russians. Walt Disney and everything just sold us on this idea of cucumbers on Mars, and so it was time to really go and do that. Optimism was pretty high that we should find at least something on Mars. All right, then came Mariner 4, the first craft to ever visit Mars, and did it reveal canals? No, it didn't. It actually just revealed craters. It looked like the moon. And not only that, the atmosphere was a tenth as thick as what we thought of it at the time. We used to think that it was about 10% as thick as Earth's atmosphere. We now know it, thanks to the mission, that it's only 1% as thick. That's really not good. So you can see that this here was based on the Navy's. So NASA was still using Navy sort of maps of Mars, and it still had canals on it. So that shows you how out of date our understanding of Mars was at the time. And this is the path that the rover took, was just a quick flyby of Mars. And these are all the images that it actually found. Craters, sand dunes, dead. Oh damn. Not very good. So what happened was we then had to wait for about another 10 years, and then essentially this lander came. And these are called Viking. Two of them landed on Mars, and it carried a bunch of scientific experiments to test for the surface of life, surface of Mars for life. This here is one of my, this is Carl Sagan, one of my scientific heroes, because he is really great for scientific outreach. And he came up with this phrase called extraordinary claims require extraordinary evidence. And this is what we'll be going into over the next few slides, because the Viking instruments found very, very interesting results. But first of all, it also returned the first images of the planet's surface. And we can see that it's full of rocks. This is essentially an outflow channel, lots of basaltic rocks, and some other pictures that don't really get shown about this area is the fact that you also get frost. Right? This is really cool. You get frost on the surface of Mars as well. So even though, it's not the best, we're not finding, space cucumbers, but we're certainly seeing that it's at least atmospherically and geologically active. There's something going on, but probably not enough to maintain sort of the optimism that the public would like. So it was also, as I said, packed with 4 scientific experiments. And these ones, I'll just quickly run through them. We have the gas chromatograph, mass spectrometer. You had the gas exchange experiment, X for short. You had the labeled release, and you also had the pyrotic release. Now, these are not exactly the easiest things to understand. So I'm going to try and distill them into a very, very simple way that hopefully most of you guys will be able to actually understand. So here we start. The first one is I'm going to go through the mass GC. So here we have is a cat. Right? Not Schrodinger's cat. I know it's in a box, but it's not Schrodinger's, it's an ordinary cat. Right? Something is very, very definitely going to happen to this cat. Right, so how are we going to test for life? So one of the best things we could do is, in this analogy, is if we have a cat and we seal it tight in an airtight box, what's going to happen to the cat? Right, any ideas? What's going to happen to a cat in an airtight box? Right, that's good, right? Because it shows that the atmosphere changed. Bad luck for the cat, but we learned that there was something alive in that box, right? Because the atmosphere changed. And that's exactly what we're going to do with this poor cat, right? So this is what they did on Mars. They got a bit of soil, they put it in a seal-tight box, and then they waited to see if the atmosphere changed, because that would be evidence of biology. What did they find? No, didn't find anything. Okay, no worries. Got 3 more experiments. Let's see how it goes. All right. Oh yeah, they also got a maybe result, which there's a lot of those in this. So the next one is the gas exchange experiment. Okay, so let's run the experiment again, but this time let's give it some nutrients, because they eat the nutrients, they'll metabolize it, and then that will change the atmosphere. So in this case, we're going to feed the cat a mouse. The cat is going to eat the mouse, and we're going to detect the cat's farts. And hopefully that's what we want to do in this analysis. Once again, the same sort of theory. The atmosphere has changed, so therefore we have proved life. What did we find? No. We did not detect. We did not detect any life with this one here. This is not looking good. Okay, so let's run a variation of that last one, where what we do is we label it with an isotope of carbon-14. So in this case we have a mouse which is full of carbon-14, and we're going to feed it to the cat, and then this time hopefully we will find evidence of carbon-14 in the atmosphere. Okay, what happened this time? Oh, that's interesting. A yes, and a maybe. Okay, but as the perspective of you might realise is that compared to, it's almost identical to the last one where we found nothing, right? The only difference is that we fed it with a nutrient that we know what was in it. And this time we didn't, but we got 2 times a yes. All right, so how about this time we feed the, for the last experiment, this is the periodic release, what happens if we feed the mouse, the labeled mouse, to the cat, right? It's going to eat the mouse, right? So therefore that carbon is going to be inside the cat in this experiment. So what we're going to do, and how we're going to get that carbon out, well, we're going to burn it. Right? We're going to burn the cat, and therefore, hopefully, if the cat ate 14C, we're going to look at that little bit of charcoal, and hopefully we'll see 14C in that charcoal, because that will be evidence that the cat ate the mouse, and therefore life. That didn't happen either. So unfortunately, in science, when you get no, maybe, no, yes, maybe, no, maybe, that is a no. Okay, so unfortunately, this was a really good attempt at trying to understand something, but you're feeding things nutrients, there's a lot of reactions going on in the soil, they're taking a lot of these things, we just didn't really have a firm understanding of what we were doing at the time. So did Viking find life? Probably no. So that's unfortunate. So as you can imagine, society, we learn about this, things are not looking good, there's no life in the soil, Mars is cold and dead, end of story, there's no stuff there. But we didn't stop looking because, we want to have a look at stuff. So this happened, this is called the face of Mars. So this is a very famous photo taken also in the 70s from the Vikings, and oh my god, finally we found evidence of civilization on Mars. The canals were right, we found all the canals, this is proof positives, fantastic. However, when we went over it with a much better camera, it looked like this. So it's just a small little mountain. So this is what we call a case of pareidolia. Now pareidolia is, right, so pareidolia is a psychological trick of the mind. So here on the left-hand side, we have a rather stoned-looking doll hat, and on the right-hand side, we have a doll which is quite surprised about his friend's illicit habit. So, unfortunately, scientists and everyone, we can also see the same thing. We evolved to look for faces. We're going to see faces where none exist. This behaviour going off in a vacuum. But what was it? What was it? Okay, so if we go back to where this is the Cydonia region, and it's right at the edge of this highlands and this lowlands area. And remember, in this lowlands area, there's potentially a lot of water and everything that's going on inside there. So what this is we think it is a pingo. Right? So a pingo is this really, really cool thing where you have solidifying ice up in tundra area, but it doesn't quite solidify entirely. You go through thaw and freezing cycles, and then eventually ice expands and you're pushing up a mountain of frozen mud. And in this case, this is what we think is happening on Mars, because we see them all along this area where we see the edges of this Martian ocean. So once again, for the next 20 years, our optimism about life on Mars is at an all-time low. And then came what I like to call the rock that launched 1,000 careers. So this is where it all happened, Building 31 in Johnson Space Center. I've been there, it's awesome. It's got the lunar vault, it's got most of the meteorites that they've ever collected. If something happens to this building, our science is done. Right? It has got pretty much everything in there that you'd ever want. It's great. And this is the rock. It's the most contentious rock in all of human history, and it has the fantastic name ALH 84001. Right? So it came from the Allen Hills region, found in 1984, the first one. And it created quite a storm, so they did a public announcement of what they found. This guy even tuned into it and gave his opinion, which was really good. So what did they find? What made this rock so contentious? Well, they cracked it open and they found it was from Mars. Well, that's not really the exciting thing. We knew those rocks from Mars. But what did they find in the rock from Mars? They found these things. Ooh, right? Now these things, they look like microbes, right? They really, really look like microbes. And there's this one here. This is probably the most famous one of all, right? The famous nanobacteria that was found inside this meteorite. So what was the cases for and against? So, well, first of all, they look like bacteria. I think you know where we're going with this one, right? That doesn't mean anything in science, right? We've got some rather scared peppers here, face on Mars all over again, but this time on the nano and micro scale. Right? Not good enough, not a strong argument. In fact, they're too small to be bacteria. They not only look like bacteria, but they're not in the same size category. They can't fit everything in there, like the DNA, all that stuff. They're just too small. Okay, they contain organics that could be biological. Okay, but they also landed on Earth, which contains organics. And we also know that meteorites land on Mars, so you could just be measuring a terrestrial contamination, or you could be getting meteorites which land on Mars and then get into the Martian soil. And so it's not really a good argument either. Alright, but fine, the carbon isotopes have a wider range of the carbon isotopes on Earth. And it's like, okay, but we don't have a firm understanding of the range of Martian carbon isotopes. We really don't know anything about the planet. So how can we really say that those reservoirs are extraordinary, right? So once again, that's not really a strong argument. And the last one is, oh, they contain some crystals in it that look like they're formed by bacteria. The thing is, these crystals, these magnetites, they can be formed by high thermal events, such as an impact, which probably got it off the rocket, off the Mars in the first place. So none of these arguments really stack up. And remember Carl Sagan's quote, extraordinary claims to provide extraordinary evidence. Nothing here is extraordinary in terms of its evidence. So, did it contain life? Probably not. But what was it? What was that feature? Well, it turns out when you're taking a scanning electron microscope image of something, you're using electrons, right? And electrons have a charge. So if you have something non-conductive like a silicate rock, it's just going to stack up on that rock and you're not going to be able to image the rock. So what geologists do, microscopists do, we put a tiny, tiny little thin film of gold or platinum or carbon on it, and that helps the electrons go across and you've completed the circuit and you can actually image the thing. The problem arises is when you put a little bit too much of this coating on top. And what they found is that these things here is just a really thick gold coat. And they glob up and everything, and that's all it was. Yeah, so did ALH contain life? No. But in a very similar fashion to what happened with the canals that these scientists made 100 years prior, over 100 years prior, and kick-started science fiction. We also had Fallout from this discovery. We saw 2 movies about going to Mars and finding life on Mars. We found the origins of the Mars Society back in 1998, and we also it took astrobiology from this fringe science thing into an actual field, because it forced scientists into the question, well, what is a biosignature? How do you define life? Because that is the sort of things that we weren't addressing when we actually found this thing. So it really started a whole brand new field of science and legitimized it. But the best thing that came out about it was it was roughly came about at the same time as funding for few robotic rovers. And it kick-started, essentially, golden age of robotics on Mars, which has not stopped to this day. So I just want to play this video, which came out roughly around about the same time. Will it work? It's a little ad. It was awesome. Had to include it. Yeah, I love that as a kid. Alright. No, not again. Alright. So, NASA really went into overdrive with this, because the public ate it up, they loved it, and we were actually getting real good science. Optimism was good again. So we're
Must have been one of the games that I haven't heard you so quiet during a lecture for a long time.
Okay, so the last thing I've heard is that thing was meant to launch a long time ago, like I think 2012. It keeps getting delayed every 2 years. The last thing which I heard, which is not encouraging, is that Russia, which is providing the launch vehicle, has been testing its parachute, and it has recently failed a milestone. They get one more test, and if they fail that, then it's delayed 2 years. So that's the last I've heard. I can't anything more. So hopefully it passes this next test, because there won't be time to do another one.
Obviously, was shot.
Did it crash?
Russia's been very unlucky with Mars. You know?
Yeah, yeah.
Already got one soft landing in 1971 with 30 seconds of TV back that we destroyed in a dust storm. And every other Russian ones who were the American have been very lucky. They've got a few ones.
If that is the case, when would be the moment where we would decide, right, there's very rarely, probably there's no life on Mars, and perhaps look at, because obviously we're going to send people over there, that's the goal, so I imagine people might want to terraform it or like populate it in some way or another, so
When do we call it that there's no life on Mars?
Yeah, that's right.
That's a really interesting question, and one that does get posed at astrobiology conferences all the time. I don't know. The point is that we haven't looked at everywhere, we haven't underturned every rock. We know that there's probably environments deep on Mars, like in a lot of water, like potential aquifers and stuff like that, and we haven't got to them yet. And we're probably not going to get to them for probably 50 years minimum. So there's a long time. So like I was saying, the whole journey for the search for life on Mars has spanned generations, gone back to the Victorian England times and everything like that. So it's probably going to continue probably for another 50, 100 years. So it's yeah, unfortunately, I don't think we're not going to answer it anytime soon. But what we have done recently is that we haven't got too excited and gone straight to look for life anymore. We've built up our knowledge base. We know the geochemistry. We know the habitability question, and now we're moving on to actually finally starting to look for it with standardized techniques, which we can look for in terrestrial analogs on it. So, chances are good that if there's something there, we should find it. But I think the most recent understanding of Mars and biosphere, if it exists today in its standard form, it's probably hundreds of meters underground.
So those salts that you mentioned were destroyed.
Yes, the florets, yes.
Probably wouldn't have ended up in fossils, but if we could.
On fossils, yeah. Well, if you can find a fossil, yeah, like a fossil preservation, they might not necessarily have much thing. But if we're looking at, say, organic, like preserved organic molecules, which could be inside there, they could be perchlorate solids with those organic molecules, and if you're getting those out, that could pose a problem. But we don't necessarily know about that yet. There's been meteorites returned from Mars, so when I mean that, I don't mean like full, I mean chunks of Mars blast off the surface and land on them. And there's been organics found in there, but we've also found tiny concentrations of the salt now that we know that it exists, so it's going to be a tough one. But if there's an actual fossil, but like I said, fossils and things that look like bacteria don't necessarily are bacteria. You need things like organics, you need things like isotopes, you need other forms of evidence to stack up, lay up an argument. And yeah, so a fossil on Mars probably wouldn't be necessarily a thing without further evidence.
People say that the comets brought life onto Earth. So can something similar could have happened?
Yeah, so I believe what you're talking about is the idea of panspermia. Right, so the idea of panspermia, for those who don't know, is that life starts on a planet, and then it gets hit with an asteroid. That rock contains some microorganisms. They travel through space, land on another planet, and potentially see that kind of new life, and life spreads that way. It could have, but we don't have evidence of Martian life really to make that argument yet. I mean, if we do find life on Mars and it shares a very similar genetic pattern, then yeah, there may have been that case. Either them to us or us to them. We don't know, but it could also be a completely new origin, a completely new genesis of life, if we find it. But as to that question, does it sound plausible that you can knock something off? It turns out that was proposed in the late 80s, and everyone went, ha, that will never happen. Then they did some experiments. They got a rock, they filled it through with some microbes, put it in one of NASA's guns, which can fire things at orbital velocities into essentially a brick wall. And then they essentially scooped that out. Yes, 99% of the bacteria died, but enough survived that they managed to culture it up. The Russians get away with things that NASA doesn't allow, and one of the really cool ones was that they got some basalt, which they inoculated with microorganisms, and put it on the heat shield of an incoming one of their capsules, and it actually they managed to still get stuff surviving to a certain degree. So yeah, it went from no, this is a joke to okay, could happen. So,
during the lecture, we heard a lot about if water does exist on Mars or not. But the question comes up is that is water something needed for existence of life on a planet, or water is something we need to live on a planet?
it's something that life as we know it needs to exist, because water, not only is water important for transferring nutrients and things around, but it's vital to actual chemical reactions. So for like catabolic reactions and anabolic actions as well. So water is very, very important, both for chemical reactions inside organisms and also for transferring nutrients. So there's nothing on Earth that is alive that does not use water. Whereas we know that some things don't need oxygen to live, such as plants. So there's some things we can get away with. We don't, but water's not one of them. Now, we could find some crazy new life made out of something else, some other silicon, for instance, but that's speculative. It's most likely carbon.
Yeah. So we know that Earth is twice as large as Mars. So does it mean that we have 8 times more time that Mars had before our core will cool down and we'll lose our magnetic field?
Yeah, we're doomed for the same fate. Eventually, we're going to lose, our Earth is going to cool off, we're going to lose our magnetic field, and our atmosphere will be eroded as well. But at the same time, Venus also doesn't have a magnetic field, and it's got atmosphere in spades. So it will happen to us eventually, but by that time, things have gone really bad for us anyway. Like the sun's 10% hotter than it is, all the oceans essentially boiled away. We're already Venus already, life's already gone. So by the time that sort of goes away, things are already bad. We've got other problems.
Any further questions? There we go, the one beautiful.
If we do find life on Mars, is there an estimation of the percentage of chances that there will be life on any of the other planets in the solar system?
Well, no one knows. The correct answer is no one knows. However, you want my speculation. So the thing is that what's really cool about it is that there's one argument, and I think it's fairly sound. If we only find one evidence of life in our solar system and it's ours, we're at a disadvantage. We don't know how much everything else. If we find a second genesis of life, or even a panspermia one, like this thing goes to another planet, then all of a sudden we've got 2 examples in one solar system. All of a sudden, the chances of finding life elsewhere in the universe starts to look really good. Because at the moment we don't know if we're just a freak, a freak chance of nature, or if it's just as common practice. Like we don't know. That is the question. If we find evidence of life somewhere else, it looks like it's the latter life form.
Any further questions? Well, thank you very much. That's so quiet by the way.
That's good.
I'm glad that you come up with lots of questions. Thank you very much for a lovely lecture. Safe journey back to Stirling. After you go back to Stirling and all that train.
We've got so many volunteers, it's crazy.
Some of us don't get that far.
Excuse me.